What's up, everyone? Welcome back to my YouTube channel. My name is Rica Casabrana from Electronics Engineering of De La Salle University Dasmariñas. And for today's electronics vlog episode, we will be focusing on the basic arithmetic logic gates, and we will be exploring their characteristics and behavior on the circuit. But before we start the vlog for today, don't forget to subscribe and hit the notification bell para updated ka sa mga vlogs ko. So what are we waiting for? Let's start with an introduction. For us to know the overview of the paper, one of the objectives of the experiment 6 is for us to fully understand the operation of the basic arithmetic logic gates. And the second objective is that we aim to emphasize the significance of the logic gates in the internal capacity of our computers. With that, we will be able to dig deeper on how computers are made through the use of logic gates, and we will be able to understand the logic and the principle behind the circuits of our computers and devices as well that we used in our modern technology for today. So what are we waiting for? Let's start the experiment.
Now, to provide us an introduction, what are arithmetic logic gates and circuits? An arithmetic circuit is a set of gates with a separate set of inputs for each number that has to be processed. The gates are connected so as to carry out an arithmetic action, and the outputs of the gate circuit are the digits of the result. Now, these are the materials or the components that we will be needing for the experiment. We will be needing one for each: a 7486 XOR gate, a 7408 AND gate, a 7432 OR gate, and a 7404 NOT gate. We will also be needing two 360 ohm resistors, two different colored LED lights. I used one green and one red for our outputs. Of course, connecting wires, and lastly, a voltage supply. Now that you're ready, let's start.
Now, for our first logic diagram, which is the half adder and full adder, we will be needing a 7486 XOR gate. Okay, so let's connect it here. And we will also be needing a quadruple input AND gate, which is the 7408 AND gate. So let's just connect the components in our breadboard. And now for our connections, we will be putting our input X to the first pin of our 7486, okay? And as you can see on the diagram, the first input of the 7486 is connected to the first input as well of our 7408, okay, as you can see here. And for our second input, which is the input Y, we will be connecting it to the second pin of our 7486, and we will also be connecting it to the second pin of the 7408, as you can see here, okay? And for our VCC connection, do not forget that this pin here on the other side will be the connection to the VCC or to the voltage supply. Okay, this is important for both of the IC here. And also, don't forget to ground the components on the 7th pin of both of the integrated circuit. Okay, let's just ground the components. And now, for our outputs, we will be needing two LEDs, okay? Two color LEDs, which is a green LED and a red LED for our sum and carry outputs. Now, for our outputs, let's connect the third pin of the 7486, this will serve as our output for our sum. Okay, this will serve as our output for sum, which will be from the 7486 XOR gate. Okay, so let's put it here, and we will also be considering the output for the sum, which is, since the wire is color green, let's just put a green wire here. Okay, this green LED will be the output for our sum from the XOR gate. And let's ground our LED here. And after grounding, we will be putting the output, okay, the output for the curry, which will be from the 7408 IC, from the third pin of the 7408 IC. Let's put it here. Okay, and our output for the curry from the quad gate is the red LED here. Okay, so let's connect it here. And of course, do not forget the grounding for our output for curry. So this will be our circuit for the half adder, which is our part 1. Now for our sum and curry outputs, let's not forget to connect 2 wires, okay, for our input X and Y. So our input X will be on the first pin, okay, on the first pin of our 7486, okay, which is also connected to the first pin of the 7408, and the input Y will be on the second pin, okay, will be on the second pin of our 7486, which is also connected to the second pin of the 7408. So X will be the blue wire and Y input will be the yellow wire. Now for our output, let's turn on our voltage supply. So if both of the A and B, or the X and Y input, is connected to the ground or 0, as you can see, the output for the sum and the curry, or the red and green LED, is 0, meaning it does not turn on. Now, if the A input is at 0, okay, so meaning if this blue line is at 0, and B input, or our yellow line or yellow wire, is at 1, as you can see, umilaw yung ating output for the sum or the green LED. But if we interchange the connection of our inputs, the A input will be connected to 1 here, and the B or the Y input will be connected to 0. As you can see, the green LED turned on, or the output for the sum turned on again. Lastly, if both of our X and Y inputs are connected to our VCC, or all of the inputs are 1, as you can see, the output for our curry bit light up. So that's the red LED here, which is our curry output. So that's our output for our truth table, namely the half adder circuit. Now for our part 2, which is our half subtractor circuit, we will be needing again a 7486 integrated circuit, and the next one that we will be needing is the 7404 integrated circuit, and the last one again will be our 7408 AND gate. Okay, so this will be the 3 integrated circuits that we will be needing. Now as you can see on the logic diagram, the pin number 1 of our 7486 is connected to to the pin number 1 of our 7404 integrated circuit. So here. Now, the second pin of the 7404 is connected to the first pin of the 7408. Now, the second pin of our 7486 IC is connected to the 7408 second pin. Now, for our output, the output D will be connected to the third pin of the 7486. So here is our third pin of the 7486, which will be our output for letter D. So don't forget to connect a 360 ohm resistor for the output. Okay, so here it is. And for our output D, we will be connecting a green LED light. Okay. And for our output for barrow, which is A prime B, it will be connected on the third pin of the 7408. And let's just connect it here. Don't forget the 360 ohm resistor para hindi sumabog ang ating LED. And of course, for our output, we will be considering a red LED for our barrow input connected to our 360 ohm resistor here. And now, let's not forget to connect our VCC connections for the 3 integrated circuits, one for 7486, one for 7404, and one for our 7408 IC. And do not forget, this is really important, to ground all of our components. First one is in our output for the barrow, which is the red LED. Our output for the difference, which is our green LED here. Okay, let's not forget to ground all of this. And of course, the grounding for our 7th pin of each of the integrated IC here on our end. So don't forget, because it's really important to ground all of our components. And of course, for our inputs, for our input X, it is connected on the first pin of our 7486. So our input X will be the green wire. Okay, let's connect it to the first pin of our IC. And the second input will be the input Y, which will be our yellow wire here, and it is connected to the second pin of our 7486 integrated circuit. So this will be our connection for our half subtractor circuit. Now for our truth table, let's turn on our voltage supply. If both of the input X and Y is connected to the ground, as you can see, our output will be 0 for the difference and for the barrow output, meaning both of the LED is turned on. It's turned off, I mean. Now, if X input is a 0, okay, let's connect it to the 0 or to the ground, and the Y input is connected to the 1 or to the voltage supply. As you can see, both of the output for the difference and for the barrow turned on, or the green and the red LED lights turned on as well. Meanwhile, if A input is connected to 1 and B input is connected to 0, okay, let's interchange both of them. Okay, X input is connected to the voltage supply and the Y input is connected to the ground. As you can see, only the green LED or the output for the difference turned on. Now, if both of the inputs are connected to the ground or their logic is at 0, okay, so as you can see, both of the output LEDs, green and the red LED, were turned off, meaning the difference and the borrow output is at logic 0. So that's our truth table for the half subtractor circuit. Now, we will be moving on to our part 2 of the experiment paper. We will be first constructing the circuit for the full adder diagram. Based on the logic diagram shown on our screen, we will be needing, again, a 7486 integrated circuit. Second, we will be needing our 7408 integrated circuit as well. And third, we will be needing a 7432 integrated circuit connected here on the latter part of the breadboard. Now, for the first connection, as you can see on the diagram, the first pin of the 7486 IC is connected to the first pin of our 7408. Also, the second pin of the 7486 is connected to the second pin of the 7408. Okay, so let's change the color of the wire so we will not be confused with the connection. And from this connection, we will be connecting our X and Y inputs. So let's treat the X input as our yellow wire connected to the first pin of our 7486, since the 7486 is connected already to the first pin of the 7408. And now, the second wire or the second input, which will be our Y input, will be the color green wire, which is connected to the second pin of our 7486, since it's already connected to the 7408 integrated circuit. Now, let's connect the pin number 3 of the 7486 to the to its pin number 12 here. So on the other side of the 7486 IC. And let's also connect another wire on the pin number 13 of the 7486 here. This orange wire here will serve as our Z input, as you can see on the full adder logic circuit diagram. Now, let's connect the fourth pin of the 7408, okay, to the 13th pin. Let's get some appropriate wire here to the 13th pin of our integrated IC, which is the 7486 integrated circuit. Also, let's connect the fifth pin of the 7408 to the 12th pin of our 7486 here. Okay. Now, for our outputs, let's connect the third pin of the 7408 to the first pin of our 7432 here, and taking note of the pin configuration of the 7408, the pin number 6 of the 7408 will be the output of the input 4 and 5. So let's connect it to the second pin of our 7432. Now, for the curry output or for the C output, we will be connecting a wire, okay, this will be for the C output, here on the third pin of the 7408. And for our input, or for our output for S, we will be connecting another wire, okay? We'll be connecting a green wire on the pin number 11 of our 7486. So let's count. So This is 8, 9, 10, and 11. This will be the pin number 11 of our 7486. And let's connect it here for our LED outputs. And of course, for our outputs, let's not forget our 360 ohm resistor here. Okay, here on our end. So for easier reference, our green LED will be our indicator for the S output or for the sum, and our red LED, okay, let's first connect a 360 ohm resistor here on our output for the curry output. So our C output will be the red LED here on the other side of our breadboard. And now for the last touch, don't forget to input our VCC on the last pins or on the 14th pin of our integrated circuits. Okay, this will be our red wire, which is our VCC connections. This is really important so that an appropriate and enough volume of voltage will be supplied to our circuit. And of course, don't forget to ground all of our components, including our integrated circuits. We will be grounding them on their 7th pin. As you can recall your pin configurations on our first experiments on logic gates. And don't forget to ground our LED lights. It's really important so that it will not be exposed to a large amount of voltage na pwedeng maging cause para sumabog yung ating LED. So this will be our last LED na i-ground natin. Okay, so for this connection, take note for our output. The yellow wire will be our input X, okay? Our orange wire here will be our input Z, and our green, okay, our green wire here will be our input Y for our truth table. So for our full adder circuit, this will be our breadboard setup. Now for our truth table, let's turn on our voltage supply. If all of the inputs X, okay, if all of our input X, this will be the yellow wire, input X, input Y, and input Z will be grounded. As you can see, both our S and C outputs, or the green and the red LED, were turned off. Now, if both X and Y is a 0, okay, so the yellow and the green wire is a 0, and the orange or the Z input is at 1, as you can see, our S output turned on, while our C output is turned off. Now, if Y input or the green line or wire is connected to the VCC or at logic 1, and both of the input X and Z is a 0, okay, so let's connect it to 0. As you can see, again, the S output turned on, or the green LED turned on. Now, if both of the Y and Z, meaning if both of the green wire here is connected to the VCC, while the input X or the yellow wire is connected to the ground, and input Z is connected to 1, meaning our voltage supply here, as you can see, our output will be C will be turned on, or the red LED is turned on. Now, if only the input X or the yellow wire is connected to the VCC and both of the green or the Y and Z input is connected to our ground, as you can see, only the S output or the green LED turned on. Now, if only the input Y or the green wire is connected to the ground or at logic 0, and both of the input X and Z is connected to the voltage supply, as you can see, only C output turned on, or only the red LED turned on. Now, if both input X and Y is connected to the VCC or at logic 1, and only input Z is connected to the ground, as you can see, the output for carry or the red LED was turned on. And lastly, if all of the inputs X, Y, and Z is connected to the VCC or at logic 0, as you can see, both of our outputs or both of our green and red LED lights were turned on. So that's our truth table for our full adder circuit. Now, for our last part of the experiment, our full subtractor circuit, we will be needing a 7486 integrated circuit. Okay, again, it will be first on the line on our breadboard. Next is our 7404 integrated circuit, second after the 7486. Next is the 7408 integrated circuit, third after our 7404 IC, and the last will be our 7432 integrated circuit, which will be the fourth IC after the 7408. Now, according to the circuit diagram, let's connect the pin number 1 of the 7486 to the pin number 1 of our 7404 IC. So here. Okay. Now, let's connect the pin number 2 of the 7486, okay, to the pin number 2 of our 7408. Now, let's connect the pin number 4, the pin number 2 of the 7404 IC to the pin number 1 of our 7408 IC. Now, as our input, let's consider the blue wire as our input X, which will be connected to the pin number 1 of the 7486. And let's consider another colored wire, which will be our white wire, which will be our input Y connected to the second pin of our 7486, as you can see here. Now, connect the pin number 3 of the 7486, which is the output of the pin number 1 and 2, to the pin number 13 of the 7486 here. So, pin number 13 is one of the inputs of the 7486. And now, for our Z input, which will be our barrow in input, let's connect another wire to the pin number 12 of our 7486 IC, or it is one of the input pin for our 7486 IC. Now, let's connect the pin number 13 of the 7486 to the pin number 3 of the 7404 integrated circuit. And the pin number 4 of the 7404 is connected to the pin number 4 of our 7408. And the pin number 12 of our 7486 is connected to the pin number 5 of our 7408 IC. Now, for the 7432 connection, we need to connect the pin number 3 of the 7408 to the pin number 1 of the 7432. And lastly, we need to connect the pin number 6 of the 7408 to the pin number 2 of our 7432. Now, for our output connections for the two LEDs, we will be connecting our white wire here on the 11th pin of our 7486, and let's put it here. Okay, and do not forget our output for the 7432 integrated circuit. Let's put it on the 3rd pin of our 7432 IC. So let's put it here. And of course, do not forget our 360 ohm resistor connection and our LED. So our green LED will be for the B output, okay, for the barrel output, and our D output will be our red LED. Of course, do not forget our 360 ohm resistor. So here. And now, the most important part is the connection of our VCC. So don't forget to put all VCC connections to our integrated circuits. So in total, it will be 4 red wires to our VCC. Okay, and the last will be here on the 7432, connected to the 14th pin of the 7432 for the VCC. And of course, do not forget to ground all of your ICs. In total, it will also be 4 grounding wires, okay, for connected to the 7th pin of each of the IC. Okay, it's important that we ground our components to make sure that it will be working properly. Okay, and the last one will be here on the last 7432 IC. And of course, it is really important to ground as well our LED lights para hindi siya prone sa punde or sudden explosion. And this will be the last. So again, take note, the green LED will be our output for letter P, which is connected to our 7432 output, and the red LED will be our output for D, which is connected to the pin number 11 of our 7486 truth table. Again, take note that our blue line here or blue wire here will serve as our X input. Our white wire here will serve as our Y input, and the third wire here, which is the orange wire, will serve as our Z input. Now, for the first condition, let's turn on our voltage supply. If all of the inputs are connected to the ground or to 0, as you can see, both of the red and green LED or the output B and D is turned off. Now, if only Z input or only the orange wire is connected to the voltage supply and both of the inputs X and Y is connected to the ground, as you can see, both of the lights, okay, the output for D, or the difference, and the output for the borrow, which is the green light, are turned on simultaneously. Now, if only input Y, or only the white wire, is connected to the VCC, or at logic 1, and both of the input are 0, okay, connected here on the other end, as you can see, okay, both of them are connected to 0. As you can see, both of the D and B outputs, or the green and the red LED, are both turned on. Now, if only input X, or the blue wire, is a 0, and both of the input Y and Z is at 1, okay, let's put it here on the other end, okay, as you can see, only the green LED turned on, or only the D or the B output, the borrow output, turned on at logic 1. Now, if only input X is at logic 1, here on the other end, and both of the input Y and Z is connected to the ground, okay, let's connect them properly. As you can see, only the red LED is turned on, or only the output for the difference turned on. Now, if both X, okay, if both X input, which is the blue wire, is at 1, and also Z input is at 1 as well, both of the B and D output, or the red and green LED, were turned off. Now, if both X, okay, or the blue wire and the Y input, or the white wire, is both at 1, okay, and the Z input is at 0, okay, let's put it here and let's connect this to the voltage supply. As you can see, both of the output B and D were turned off. Now, if all of the inputs X, Y, and Z are connected to the voltage supply, both the D and the B outputs, or the green and the red LED, were both turned on. So that's our truth table for our last logic diagram circuit, which is our full subtractor circuit.
As our conclusions, a half adder is used to add two 1-bit digits, and this, once the carry is generated from the previous addition, it cannot be added to the next step. The half subtractor is used to perform subtraction of 2 bits. It has 2 inputs, the minuend and subtrahend, and 2 outputs, the difference and borrow out. A full adder adds 3 inputs and produces 2 outputs. The first 2 inputs are A and B, and the third input is an input carry as C-in. The output carry is designated as C-out, and the normal output is designated as S, which is sum. The full subtractor is used to perform subtraction of 3 input bits, the minuend, subtrahend, and borrow in. The full subtractor generates 2 output bits, the difference and the borrow out.
So that's all for our experiment. I hope you learned something from our digital electronics episode today, and I hope that I will be seeing you again on our next episodes. See you and enjoy! Bye!